Hello and welcome everyone. I'm Dr. Andrew Kaufman and I have a special treat for you today. I have a new PowerPoint slide presentation and today I'm going to be talking to you about Cox postulates. I know many of you have been asking questions about that. I'm going to share my screen now. I'm sorry about that one. I chose the wrong thing. So here we go. As I said, the title of today's presentation is Cox postulates, have they been proven for viruses? Or the rooster in the river of rats. And please visit me at my website, andrewkaufmanmd.com, where you can request consultations or interviews. You can ask questions, leave general comments or other feedback, or just in general get in touch with me. And the name of my YouTube series is called Medicamentum Authentica. And it's on my YouTube channel under Andrew Kaufman. And I also have a channel on BitChute, Dr. Andrew Kaufman. So please find me there as well. Okay, so let's talk about what Cox postulates are. So there are 4 postulates, and these are some common sense rules that were formulated originally in the late 1800s to provide a way to determine if a microorganism or germ causes a disease. So the first postulate is the microorganism must be found in abundance in all organisms suffering from the disease, but should not be found in healthy organisms. Pretty common sense. Number 2, the microorganism must be isolated from a diseased organism or a person and grown in a pure culture. 3, the cultured microorganism should cause disease when introduced into a healthy organism. So once you've isolated it from a sick person and purified it, then you can put it into a healthy person and cause the same disease. And 4th, you must be able to re-isolate that organism from the person that you made sick. And if you can do all these steps, you've proved pretty much conclusively that that microorganism or germ causes the disease. So I came across this article that some of my viewers sent me, and it claims that Cox postulates have been fulfilled for the SARS virus. And this was published back in 2003 in Nature, which is one of the most prestigious scientific journals. And this is really important to point out because I have been saying that Cox postulates have not been fulfilled. And this is also important because the SARS virus is SARS-CoV-1. In other words, the other virus that supposedly is related to SARS-CoV-2, which is another name for COVID-19. So this is the precursor virus to the current COVID-19 situation. So it'll give you a little bit of a historical background. So I want to point out that right here, just between the title and what they say in the body of this article, already they're misleading you. Because in the second paragraph they wrote, according to Cox postulates as modified by Rivers for viral disease. So it's not Cox postulates, it's Rivers criteria, which is different. And they should have put that in the title, but they're misleading you to make you think that Cox postulates have been fulfilled. According to Rivers, there are 6 criteria to establish virus as a cause of disease. And I'm going to tell you what those 6 criteria are. And I'm going to compare and contrast that to Cox postulates. So you'll see that the color coding tells you which matches up with which, so you can see that there is quite a bit of overlap. So the one that that Rivers did not require was that the microorganism is found in ill but not healthy people. So that seemingly was too difficult to prove for Rivers, but I feel that this is a major shortcoming. Because if you can't find a virus in a sick person with the disease that you're looking at, then how can you really say that it causes that virus? However, I'm going to give it a pass because they're using the Rivers criteria, so I will apply the Rivers criteria. And you can see that it definitely requires isolation of the virus from a diseased host, just like Cox criteria. And also, there's a slight difference in how it's cultivated because viruses are not living organisms. They can't reproduce on their own. So you cannot grow them in a pure culture. So for example, if you isolated, let's say, Staphylococcus from a sick person, you could grow that Staphylococcus in a pure culture that will only be Staphylococcus cells. But with a virus, since they can't reproduce and they're not alive, you can't grow them in a pure culture of just virus particles. So you need to have host cells. So that would be cells basically from the person who is ill or the source of the virus in the first place. Now, there's the third criteria of Rivers, which is not in Koch's postulates, which is proof of filterability. And this is important because the virus particles are very, very tiny in the nanometer scale, which is a billionth of a meter. And so if they have a filter with very, very small pores, much smaller than the masks people are wearing, only the particles that are considered to be a virus can pass through, and all of the other cells, like the host cells or any bacteria or fungal cells that are in the mix, will get filtered out. So this is a way to purify the viral particle. Number 4, you must be able to take that isolated particle or virus and put it into a healthy host and cause the same disease. So that's the same as the third criteria of Koch's postulates. And this is the criterion that is the most important for proving that this agent causes a disease. You can't say that it causes a disease without this step, because before that, even if you find it in people with the disease, it's just an association or a correlation, and that does not prove causation. And I'll give you an example. Let's say that you show up at a fire and you see there are firefighters there. Now, you can't assume that the firefighters caused the fire just because they're there. They're just associated with the fire. And actually, they're doing the opposite. They're putting out the fire. So you can be really confused without this step. Then the fifth criterion is re-isolation of the virus. So that's from the person that you produced the disease in. You can once again isolate that particle or agent from that person. And then finally, the detection of a specific immune response to the virus. And this is much more difficult to prove because of the specificity issue. But I'm not going to really cover that very much during this talk, because it is, in my opinion, the least important of the criteria. So notice what is not in Rivers' criteria. There is nothing about genetic material, DNA or RNA, mentioned at all. So in other words, you don't even have to look at the genetic material in order to prove these criteria. And at least formally, the genetic material or specific sequences does not have a role in proving that a virus causes a disease. And I'm following, this is what is specified in the authors of the Nature paper. So I went and looked at Rivers' article from 1937 where he laid out these 6 criteria. And I found a few interesting quotes to help us learn a little bit more detail what he was saying. So the first quote: "Now it is possible to bring excellent evidence that an organism is the cause of a malady without complete satisfaction of Koch's postulates." So basically he's saying that you can skip the steps that are not included in his criteria and still prove that a virus causes a disease. Next quote is, "Particularly those diseases caused by viruses, the blind adherence to Koch's postulates may act as a hindrance instead of an aid." Well, I think this indicates that he may have been looking for a little bit of a shortcut, that maybe it was difficult to perform some of the steps, and this makes it a little bit easier to prove a virus is the cause of disease. And it's not good to let your outcome affect your reasoning when determining these things, but I'll still accept the Rivers criteria as valid. He said, "It's obvious that Koch's postulates have not been satisfied in viral diseases." Now, granted, this was in 1937, but up to that time, that was certainly as true as it is today. He also said, "In the first place, it is not obligatory to demonstrate the presence of a virus in every case of disease produced by it." Now, I really don't understand the reasoning behind this, because if the virus is not present, then how could you say it caused the disease? But once again, I'll accept these criteria since this is what the authors laid out. And the last quote: "Viruses, whether they are parasites or fabrications of an autocatalytic processes, are intimately associated with host cells." So this is really important because it indicates a degree of uncertainty about the nature of viruses. And when he says that they are fabrications of autocatalytic processes, what I think that means is what's called apoptotic bodies. So our cells undergo this programmed cell death called apoptosis or apoptosis. And this happens in response to various things. It could just be a natural occurrence, but if there is a major illness, then cells might undergo this process, and they basically fragment into little blebs, and these little bodies, I think, are what he's calling the fabrications of an autocatalytic process. But that's very different from a virus, because that actually comes from our own cells rather than from outside. And he definitely points out the intimate association with the host cells, which is very important in the experimental methods that I'll get into. He also said something very important about how you prove the criterion where you put the isolated virus into a healthy person and cause the same disease. And what he said is, by means of inoculation of material obtained with patients with the natural disease. Okay, so not something made in a laboratory or from a laboratory, but from another patient with the natural disease. That's very important. He also said if the inoculated animals become sick or die in a characteristic manner, which means having the same symptoms as the original disease, and if the disease in them can be transmitted from animal to animal by means of inoculations with blood or emulsions of involved tissue, free from ordinary microbes or rickettsia. So in other words, give them a bodily fluid that has been filtered so that there are no other organisms in that can confuse the issue. It has to be purified. Says one is fairly confident that the malady is the experimental animals is induced by a virus. So basically what he's saying is if you apply his criteria, it's not certain, but you can be fairly confident that the virus causes that disease. So that is not very inspiring of confidence in me, but nonetheless, that is what he said about these criteria. So in other words, even if all 6 of the criteria are satisfied, that only leads you to be fairly confident, not conclusive, not certain, not 100%, just fairly confident. Okay, so let's get back to this Nature article now that we've reviewed the background information. And it goes on to say that the first 3 Rivers criteria, which is isolation of the virus from a diseased host, number 2, cultivation in host cells, and number 3, proof of filterability, have been met for the SARS coronavirus by several groups. And you see at the bottom these footnotes 2, 3, 4, 5. So I'm going to go through, and they are also in the article here at the top. If I can put my cursor is visible here. So 2, 3, 4. Oh, sorry. This is from a different paper. This is from the one before. So it's at the bottom of this, 2, 3, 4, 5. But I'm going to give all the references in each slides because I went through all those papers. And number 2 is actually the Rivers paper, I believe. But let's see. So before we get into those papers, I just want to go over the definition of isolate, because I think that this has been confused by some of the scientists as to what it means and what procedure they're using. So this is from the Merriam-Webster Collegiate Dictionary, and it says, especially, to separate from another substance so as to obtain pure or in a free state. So in other words, nothing else is mixed with it. Very key.